So here's number 24. Similar to number 23, this is something that we just didn't get to in our Thursday and Friday group review for the momentum test. Also similar to 23, this is really, really intuitive, and I don't think you'll need any help with it, but I promised you a video, and I didn't want to go against that. So here we are. Number 24, two astronauts are floating motionless next to each other during a spacewalk. The more massive astronaut suddenly pushes the smaller astronaut away from him. Okay, let's pause there to just say that the big astronaut sounds like a jerk. That, or maybe he was aware of some sort of imminent danger to the smaller astronaut. I don't know, but it seems more likely to me that this was just a jerk move. Okay, back to the question. Which of the following statements must be correct concerning the speeds of the astronauts after the push? Select two answers. So A is our first option. Both astronauts will be moving at the same speed because the two astronauts are weightless. Okay, they're weightless. So what? Maybe they're both wearing green underwear. It doesn't matter. All kinds of things may be true of these astronauts, but their weight isn't important in solving this problem. Weight and mass are two completely different things. We remember this from 9th grade science, right? Mass is the amount of matter in an object, and weight has to do with the relationship between that matter and the gravity of whatever planet we're on. All of these force and motion and momentum problems don't talk about weight at all, right? They talk about mass. So A doesn't make any sense. We can move on. B says the less massive astronaut will be moving faster because he has greater acceleration. Okay, this makes sense, right? We know that momentum equals mass times velocity. That means that velocity has to be inversely proportional to mass. And along with velocity come other types of measures of movement, like, for example, acceleration. So the less massive astronaut has to have greater velocity in order for him to have the same momentum. By the same token, the more massive astronaut will have to be moving more slowly at this point. So we can circle C, or B. B makes sense. Let's go on to C. Both astronauts will have the same momentum. Yeah, this is the easiest yes in this list because we know that momentum will be conserved. We can go ahead and circle that. Now let's look at D. The more massive astronaut will be moving faster because he has more momentum. Again, because we know the law of conservation of momentum, and we know that in these cases mass has to be inversely proportional to velocity, we know that D doesn't make sense. We're not going to circle it. So B and C are good answers. A and D are not. Again, I think you could have gotten that without me.